Chapter 4, Part 3, IPv6 access control lists. Here we go. So with those IPv4 access control lists, with a lot of stuff in IT in general and Cisco in specific, there's a lot of cruft living out there because when we first brought on this thing, it could only do this. And now you've got all this stuff in the wild and everybody's configurations are written. So we have to keep the stupid standard numbered only access control lists in place so we don't break a million people's lives. But we've sort of decided it's better to have named access control lists. And we've sort of decided that the extended access control list functionality is where we want to be at. So IPv6 rolls around, we have to add it in there. So now IPv6 does basically what named extended access control lists do in IPv4, because we've sort of had some time to think about it and we like the way that works. So that's the way it works. So IPv6 does this thing called neighbor discovery. Hey, what's up? Sends an ICMP message, sends it back, off it goes. The first difference is that to put it on an interface in IPv4 land, it is called an access group. Well, to make your lives a little more challenging, when you do it in IPv6, we decided that filter was probably a more accurate description of what's going on. So IPv6 access control lists are IPv6 traffic filters. Instead of using wildcard masks, we've decided that we'll use prefix length to indicate how much is going on there, because those wildcard things were kind of stupid and you could shoot yourself in the foot with them if you weren't very careful with them. The addition of 2 implicit permit statements is the last one. At the end of every IPv4 statement, there is that implicit deny that I was talking about. So at the end of every IPv4 statement, it says, although it doesn't say, deny any, deny IP any. IPv6 includes a similar deny IPv6 any. It also includes permit ICMP and permit ICMP to make sure that this whole ICMP neighbor solicitation business doesn't break when you put on your first access control list. So far, so good. It's got to do with these whole neighbor discovery, neighbor solicitation, and neighbor advertisement business that lets routers figure out what's up. We don't want to block those. So unless you explicitly block those particular ICMPv6 things, they're going to continue on. And neighbor advertisement and neighbor discovery and neighbor solicitation will be permitted by default. Although if you want to, you can go ahead and break that. But do so on your own time. So here we go with an IPv6 topology that looks significantly like our old IPv4 topology. We've got 3 subnets: 2001 Debate Cafe, 10, 11, and 30. It's 2001 Debate Cafe 10, 11, and over here on the other side of router 3 is 30. And then 2 connected routers that we've decided to cleverly name Debate Feed 1 and 2. Debate Feed 1, Debate Feed 2. And if you looked at their networks, you would see those things configured thusly. And if you wanted to make this network on physical hardware, you can copy and paste all of this kind of stuff into their configurations. Although you'd have to substitute serial 00 with some gigabit interface in our network. So router 1, router 2, and router 3. There's our default configuration, which looks a lot like the configuration we did for IPv4. The syntax is largely the same. You've got IPv6, access list. Give it a name. Is it a permit list? Is it a deny list? Pick your source with an IPv6 address and its prefix length, and then its destination. Any is /0. Host is a specific host. You can play that less than, equal than, greater than, not game again. And you can also enter in the port numbers for filtering TCP or UDP. So very much like the way we did it on IPv4. So in this case, we are going to configure an access list that denies access from router 3. So we create an IPv6 list on router 1 called no router 3 LAN access, and it denies anything from 2001 debate cafe 30/64 any. We attach a permit any statement so we don't block all the traffic when we turn this thing on, and end it. It's a lot like the way we blocked IPv4. Off you go. You put that on router 1, and all of a sudden router 1 can't hear traffic. Wait, we haven't applied it yet. So it's still traffic flowing. We've got an access list. We need to apply that to an interface, and then we'll start dropping packets. So we go into interface serial 000. That's this guy right here. We attach the megaphone to the serial interface with filter, with funnel. And then again, it's not access list. Now it's IPv6 traffic filter because we weren't willing to live with that other one. The name of it, no router 3 LAN access with hyphens in between it. And we're worried about inbound traffic. You could do it with outbound traffic, but then the traffic would come in, talk to the computer, it'd try to go out, there'd be sadness. So that's bad. Here's a couple of examples. Here's our routers as we had them set. Say we want to deny FTP to network number 11. Well, do it thusly. Remember, we've got to deny FTP and FTP data. We've got to turn on our permit any to override the explicit deny, pick our interface, apply it to our interface, tell it that it's on inbound traffic, and the next thing you know, we've managed to restrict FTP access on the way in. So what if you wanted to verify that? You could do show IPv6 interface, and that would verify that you actually attached it to a interface. In this case, line 00 is up, and there is an access list called restricted access messing with the inbound network connections. You could show access lists, and it would tell you that you created an access list called restricted access and what you told it to do. And in this case, we've permitted anything from debate cafe 10 on www or 443, which is HTTPS, and denied anything from debate cafe 10, and anything from host debate cafe 3012 going to host debate cafe 11. And we furthermore denied telnet. Whew, it's a pretty restricted access. And if you do your show running config, you will see that listed when I start getting to the part of the configuration that talks about IP access lists. Lordy. So there is a packet tracer where we will go through and create us some access lists, and a lab that you may do alternately if you have access to our real-world equipment, or heck, even in your own real-world equipment. So what's that logic look like? Why do we put that where we put that? Well, we did do a little thinking about that ahead of time. If we start looking at access control entries, so we talked about access control lists, the ACLs, an access control entry is an individual line inside of that list. Keep this in mind when you're trying to figure out how to build those access control lists and the entries that go into them. You want to get out of this loop as fast as you can. So notice that we start with an inbound interface. We hit our first access control entry, and so if that's the one that's the broadest, it should be the one that's first. And And if it doesn't match that, we move on to the second one and the third one. And if we didn't turn on an entry that overrides this implicit deny any, it goes in the trash. That's why that last entry in most of our access control lists is an access control entry that says permit any. So your packet comes in here, it doesn't hit this one, it doesn't hit this one. It is part of any, so off it goes into the routing table. Otherwise, into the trash. And again, just to beat this dead horse, the idea here is that we reduce the amount of thinking the router has to do about this packet that it eventually is not going to care about. So the faster you can get it tossed out, the better out. Same thing happens on the way out. So now it's gone through that first process if there's an inbound ACL, and it has gone through the routing table, and we have figured out which interface to send it out of. If there is an access control list on that outbound interface, the same process takes place. Does it match the first? Does it match the second? Does it match the third? If the third is not something to override the implicit deny, then it goes in the trash, which maybe is what you wanted. But maybe not. Maybe we had some specific access control entries for 1 and 2. The third one is allow any. The packet continues on its merry way out of the outbound interface and onto our network and does good things. So we just want to keep those things in mind as we design these things. What if we had some lower level controls? So what if a frame shows up on a router interface and does not match something in the layer 2? So a frame for 192.168.1.3 on a router that's 192.168.1.1, we toss it. Well, I guess that's even layer 3, so it would have to be a MAC address, Debate Cafe, Fady, or whatever. And the actual interface is MAC address, Debate Cafe, Fady 1. We still do the same thing. Is there an access control list? If there is not, we continue on. If there isn't, we go through the entries on that access control list, one of which is the default deny that we need to keep in mind. Otherwise, we permit the packet, forward it to the outbound interface, and then we have to check and see, is there an outbound? And the whole thing repeats. Eventually, the packet gets forwarded on. And you can see how like adding these layers of thought all require processing power. Standard ACLs work much the same way. If we get a packet in, is there an ACL on the interface? If not, do we know how to route it? If so, we route it. If not, we trash it. Otherwise, we apply the access control list. Does it match an entry? Yes, no. Move on to the next statement, and so on and so forth. If it's a permit or deny, if it's permit, it goes. If it's a deny, it gets dropped, and so on. Extended access controls, much the same, but a little different. So if there is no access control, we just route the packet. If it's in the routing table, it goes on. If it's not, we don't. If there is an access control, we go through the ACL list, we look for the address, then we look for the port, then we see if it matches. If the destination, protocol, and port all fit, we permit it to go on. And if it doesn't meet any of those conditions, it gets tossed. We iterate that through each access control entry in the access control list until we get through. And that's as much talking people through pseudocode as I care to do in one day. Did you get the idea? Make sure it's destined for us. If it is, decide if it's incoming, outgoing, work it through the decision tree, and off you go. So sometimes we need to troubleshoot those. Frequently, we will make a typo. So the tools in our toolbox, again, consist of shell commands. And here we're going to look at our access control list, and we're going to discover that we are denying bunches of requests, apparently 12 of them all said and done. where we deny anything on this network on router 3 because of the access control list up here. So if that's not what we want to do, assuming we're not intending to block all these things, we should look at the order of the access control lists. If rule 10 here, which is denying 192.168.10.0, comes before rule 20, which permits stuff from 192.168.10, assuming it's telnet, we have a problem. What do you think that problem is? Right, 10 and 20 in their entirety should be switched around, right? Because if we say, all right, line 10 is deny anything from 192.168.10.0, if I get a telnet packet coming in from 192.168.10.0 and it gets to line number 10, we're going to throw it away right then and there.
Well, I guess let's let that telnet in.
Maybe this is actually not a bad idea. But that's what they're trying to let you know. Get rid of those little logical bugs before too long. In this one, we have a little problem. We're trying to use TFTP to go through our network, and yet we fail. We are only trying to deny telnet and SNMP, and we've got to permit TCP any, yet we can't use TFTP. Why is that? And I've cleverly covered the screen with my rescue time alert to ensure that we can't get that through. So why is that? That we can't TFTP through that, even though we're permitting TCP any. Here's a hint. Right, those evil geniuses who created TFTP used UDP, and we are only permitting TCP to go through our network. So we're dropping all of those UDP packets as they come across. So what we really meant to say was permit IP any, and that would permit TCP and UDP. And then everything is cool. We don't have all these problems. So let's see, in this one, the network can telnet to 192.168.30, but we should not be allowing that. And we look at our access list here. It says access list, extended access list, deny any that equals telnet to any. And then deny TCP blah, 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 host equals SNMP, and then permit TCP any. What's going on with that? So let's draw that a little bit, shall we? 192.168.11/24, this network here, can connect to 30. It's this guy over here. But that should not be allowed. ACL 130 on router 1, which we're going to assume is on gigabit 0, says deny telnet This one's cheap because I don't think you could figure it out.
I think the answer is because the telnet port for statement 10 this 30 listed in opposition to the ACL statement.
Does that because statement 10 currently denies any source packet with a source port that is equal to telnet? Or maybe spoken more generally, I think the only way you can really even tell that is because the funnel's facing the wrong way. But so like what it's saying is we're going to deny something from the wrong side. So if you say deny TCP from there to there equals telnet, it straightens out. That one feels clear as mud. Here's one. So 10.12 is able to telnet to connect to 31.12, but we don't want to allow that. So there's our policy. And it says deny host equal to 30.1, anything equaling telnet. Well, so deny TCP host 192.168.30.1, and yet we can still get traffic from 192.168.30.12. So basically what we're saying is this, we're going to deny this particular host, 192.168.30.1, and then we're going to cry because 192.168.30.12 can get there because we told it about a different freaking computer. They forget, either they fat fingered the 2 or maybe they had even intended to make it like a network filter and block everything over there. Here we go again. Now 192.168.30.12 is up to no good again with this stupid telnetting and can still get to 31.12. Son of a gun. Here's ACL 150. Deny 31.12 telnet. And I think we just screwed around and put that on the wrong one.
Wrong router.
Son of a! At least they didn't put it on router 1. The filter should be applied to the outbound, not the inbound. Because of the direction that the access control list is applied. It's another one where like, we're not going to tell you anything useful. We're just going to show you this filter thing. You're going to have to remember from previous sessions when we told you which way that filter had to go.
Does that say router 2 or router 3 in the command?
Router 2. Oh snap, you're right. Yes, we certainly should apply it to the right router.
Is that the answer, or did they mess up another slide?
I think they might have. It was just a little bit off here. Let's see, what does the solution say? Host, blah, blah, can use telnet to connect because of the direction in which, yeah, I think that, here, let's fix their slide for them.
Just briefly explain the syntax.
So 10, deny, TCP, any host from that is telnet. Right? Permit any. Does that breakdown work for you? And you're right. It should be on router 3, I think is what we intended to say there. So pretend that says 3. And what they're trying to show in the picture is that it should be applied on the outbound filter to prevent this business from happening. But instead is it applied on the inbound filter, which would prevent this business from happening, which isn't what we're concerned with. And I tell you what, Let me bring back up the breakdown for you of how those things look. So we start with the list, the number. Are we permitting, denying? You can also use it to make your comments. The protocol, the source and the source wildcard, the port or the port name, destination port. Help a little bit at least. So we've troubleshot our ACLs. IPv6 example numero uno. Hopefully we didn't put any of these on the wrong router. So our goal, let us deny FTP access to the 11 network. The problem, in addition to this being a little bit complicated, is like the language is murky there. Deny access to the 11 network. Does that mean we want to deny the 11 network the ability to FTP out? Or does it mean we would like to deny access from other hosts into the 11 network? Both of which are valid readings of that sentence. Let's see if it becomes any clearer. No FTP traffic to 11 is what we're going to use to do that. All right. And they're going to solve that by putting this access control list on router 1. We assume this time they got the router right. That seems right. Router 1's right next to network 11. They created a filter called no FTP traffic to 11. We configure it, and yet, PC1, this guy right here, 2001 Debate Cafe 10, is still able to go through router 1 to switch 2 and FTP into PCP2, despite us naming this thing no FTP to 11. We even gave it a name that says, hey, we don't want any traffic going through. That looks, whoops, like I went back one too far. That looks legit. What else is going on? So we should look at our connection interface, gigabit 00, no IPv6 filter, IPv6 to blah, blah, blah. Oh, we move it from out to in, and it works again. Again with the point of which direction the funnel's going. They're really trying to pound that idea home. That sometimes if we're trying to deny FTP access going into PC12, you probably want to have an outbound filter here so you can block stuff from over here and from over here. Example 2. This one's complicated. We're going to permit access to the 10 network. We want to deny access to the 11 network. We want to allow PC2 over there in 2008 Debate Cafe 11 to SSH. We want to allow SSH access to PC2. So we configure that and then we screw it up. Who knows? We create one called restricted access. It does all this. Permit Debate Cafe 10, deny IPv6 any. And then permit Debate Cafe 11 equal to that. Uh-oh. Take a look at it. Looks like the ACL's spelled right. It looks like the direction and location are right. However, We put the order in the wrong, put this deny in front of this permit. That's going to get up to no good. Then they put a host statement in instead of a network statement. They've just gone all kinds of crazy on this one. So to straighten it out, you remove that host argument because what you really intended to do was to do the whole network. I had kind of highlighted that. Maybe you want the actual whole Debate Cafe 11 network to go through. Straighten it all out, and it should look something like this. We put the permit statement above the deny statement. So now we're going to permit SSH before we deny everything on that network. And it all works. Like magic. Here we permit access to 11, deny access to 10. Seems straightforward enough. Yet, still, Cisco can't figure out how to do ACLs correctly. So this time they've created this ACL called deny access. It permits Debate Cafe 11. It denies Debate Cafe 10. There's probably a glaring error there. Then we go into gigabit interface 01. They don't do it. Alas, that's a problem. Then they go and they remove the ACL on router 1, apply the correct configuration, and make it all work. Permit 11, deny 10. We'll also deny everything else as long as we're at it. That was the error that stuck out of me. And after all of that, 7 delightful examples of different ways Cisco can fail to set up their own access control list. Now you too can go and troubleshoot access control lists. And we will probably pay that game, not next week, but the week following, I think. And then we'll integrate all those skills together in some sort of challenge. So is anyone still awake? No? Member access control lists, show the interface. We call it access class in IPv4. We call it a traffic filter in IPv6. It's all very exciting. I applaud you for staying awake.